says, which of the following isoelectronic species has the smallest radius? Well, before I answer this question, let me just talk about radius in general. And I'll draw the shape of the periodic table, sketch it anyway. So there's a rough picture of the periodic table. We can put in fluorine and neon just to get our bearings. First thing I want to do is I want to talk about just the atomic size, which so sometimes we call it atomic size or atomic radius. And we're going to talk about the atomic size or atomic radius. Those are two ways of saying the same thing. Trend for atoms. Not ions, these are ions, but just atoms. And the trend goes like this. As you go to the left on the periodic table, and as you go down each column of the periodic table, atomic size or atomic radius increases. So I'm just going to write, well, since we're talking radius here, I'll write atomic radius increases. And going down, atomic radius increases. And that is always true. And we will talk about why that is in a upcoming homework question. So if this question instead, and I have a feeling this is coming up, but so if that question said, which atom is larger, oxygen or fluorine, you would say, as you go to the left, atoms get bigger. Oxygen is to the left of fluorine. Oxygen is bigger than fluorine. If the question said magnesium or calcium, which atom is bigger? As you go down, atoms get bigger. Calcium must be bigger than magnesium. All right. Now, and we'll talk about why that is. But in this one, we are now talking about what's called an isoelectronic, isoelectronic series. And let's break down the phrase isoelectronic. Iso means same. Electronic means electrons. So what we're going to see is all of these species have the same number of electrons. And I'll write them out down here. N3 minus, magnesium 2 plus, sodium plus, and oxygen 2 minus. And what's different about this, so these all have the same electrons. But let's look at number of protons first. So number of protons, if you remember, we can look right at the periodic table, and the number above each element is the number of protons. So let's see. Nitrogen has 7 protons. Magnesium, element 12, has 12 protons. Sodium has 11. And oxygen has 8. Okay? So clearly the number of protons is different. Now let's check in with our number of electrons. For our number of electrons, if there are 7 protons and the charge is 3 minus, that must mean that there are 3 more electrons, so there are 10 electrons. Now, magnesium 2 plus, if we have 12 protons and a 2 plus charge, that means we must have taken away 2 electrons. Now we have 10 electrons. And what you'll find is, true to the problem's statement, all of these species have the same electrons, but they have different numbers of protons. So let me check in. Any questions about the answer or the results that I have right here so far? Because I can say more about figuring out numbers of protons and electrons if you'd like. But if you're good, then we'll move on. Okay, so same electrons and different protons. What you can imagine is the one with the most protons pulls the electrons, right? Because that's positive charge. That's what the nucleus is. Most protons equals most positive nucleus. In fact, magnesium's nucleus is plus 12 because it has 12 protons. So most protons equals most positive nucleus equals most pull of electrons towards the nucleus equals smallest species, I guess we should say, smallest ion. All of these are ions. So let's just say, how about this? Smallest radius. So our answer will be the magnesium. And our logic is, if all the electrons are the same, then the one with the most protons will pull the electrons towards the nucleus and end up with the smallest radius. Any questions about that?